Welcome friends. In this video we are going to look at the science paper 1 and we are going to look at the random questions. We'll make sure that we see how we can summarize grade 10 work, 11 and then we'll finish with grade 12 work. So let's look at the first question. So under grade 10 work we are expecting to maybe encounter a question where we are given this measuring device. So question 1, figure 1.1 shows a measuring device. Then the first question is name this measuring device. So whenever we have this structure, just know that we are dealing with a micrometer screw gauge. Then after this question, we have question B, where we are taught to find the reading shown on the device. So first we need to look at where our main scale is. So this is where our main scale. Then our vernier scale. Vernier scale means a scale that is moving. So first look at how do we find the reading in the main scale? So the main scale, we just have to count whatever that we have on top here. So we can see we have 5. This is number 6, 7, 8. So the number before this vertical line is 8. Now below 8 we have this smaller line here, so you just have to add 0.5 to whatever number that we have on top. So since it's 80, we add 0.5, so this becomes as our 8.5 millimeters in main scale. Then from there we'll look at from the vernier scale. So from the vernier scale we need to look at a horizontal line that is coinciding with the main scale and the vernier scale. So whatever line that we have here, so you can see that if this is 20, 21, so this is on 22. The rule is whatever number that you get on the vernier scale, you multiply by 0.01. So if you multiply this, you get 0.22 millimeters. Then we just have to add for us to find the reading. So we'll say 8.5 plus 0.22 millimeters. Then if we add 8.5 plus 0.22, we are getting 8.72 millimeters. So this is our final answer. Then we have question C, state 2 precautions to be taken when using this device. So the precautions is, what are we supposed to do to make sure that we get the accurate reading? So the first one, by make sure that we zero our device. So say zeroing the device. Zeroing the device means making sure that the readings are 0 before you do whatever that you are going to do. Then the second one, we have to make sure that we clean the device, because the micrometer screw gauge is so sensitive that it can even measure the diameter or the thickness of a dust particle. So clean the device. Then the other questions that we may encounter here is the use or the importance of micrometer screw gauge. So micrometer screw gauge can be used to measure thickness. So thickness of the first one, wire. Then we have metal sheets. Then from there we have ball bearings. Apart from ball bearings, it can also measure the diameter of rods. So these are the questions that we may expect under final examination under simple micrometer screw gauge. Then question 2, we'll just look at a simple pendulum. If we encounter a question on a simple pendulum, what cases can we expect and how can we handle such questions? So figure 1.1 shows a simple pendulum, and we have a fixed simple pendulum because of these lines here. Then the questions are, the first one, if the bob of the pendulum takes 0.5 seconds to swing between extreme positions A and C, so from A up to C, we can see that the time taken was 0.5 seconds. Then the first question is, what is the period of oscillation? So the symbol for period is capital letter T, which is equal to small letter t, time taken over number of oscillations. Now we have time, then we just have to find the number of oscillations. So the number of oscillations, if you are not given, if they have not mentioned, how do we count the number of oscillations given a question like this? So what are we supposed to do? So what we are supposed to do here is, first we need to look at if the bob moves from point A to B, how many oscillations have we made here? So this is just a quarter, which is 1/4. Then from B to C, it's 1/4. Then C to B, 1/4. B to A, we have 1/4. So we know, and I'm sure yes, we know that if a bob moves from point A to C and back to A, that is what we count as one oscillation. But let's see if we can prove by these numbers. So from A to C, we can see that we have 4 quarters. Let's see if we add 4 quarters. So we say 1/4 plus 1/4 plus 1/4 plus 1/4, which is here we are going to have 4 as our lowest common denominator, which is 4 into 4 is 1 times 1, we have 1 plus 1 plus 1 plus 1, which is the numerator is 4/4. 4 into 4 is 1. So that's how we calculate 1. Now let's say if this bob moves from A to C. So from A to C, how can we count the number of oscillations? So A to C, you just have to say 1/2 plus, 1/4 plus 1/4. Lowest common denominator is 4. 4 into 4, 1 times 1, which is 1. 4 into 4, 1 times 1, which is 1. 1 plus 1 is 2/4, which is 2 into 2 is 1, 2 into 4. So whenever a bob move from A to C, the number of oscillations here, N, must be equal to 1/2 or 0.5. Then what if from A to C, then back to B? Then this, if we do the calculations, will give us 3/4. So this is what you can use whenever you are dealing with a simple pendulum. So we can say T is equal to 0.5 seconds over, then N is also 0.5. 0.5 into 0.5 is just 1 second. This means that for one complete wave or for one complete oscillations to be produced, 1 second elapsed. Now let's see if this is making sense, because we define period as the time taken for one oscillation to be produced. Now remember, from A to C is 0.5 seconds. Then for us to have one oscillation, this bob must move from C back to A, which is another 0.5. So 0.5 plus 0.5 will give us 1. So that's why we say the number, the period here will just give us a 1. Then let's go to question B. Under question B, calculate the frequency of the pendulum. So we know that T frequency is 1 over T, which is 1 over the period is 1, which is 1 into 1 is 1 Hz. So frequency is defined as the number of oscillations produced per second, and we know that in 1 second 1 oscillation was produced. Then the same frequency can also be found as N over T, which is T is 0.5, N is also 0.5, which is also giving us 1 Hz. Then here we have state whether the frequency of oscillation will increase, decrease, or remain the same if the first one we are told the length of the string is increased. So if we increase the length of the string, will the frequency decrease, increase, or remain the same? So we know that if we increase the length, the period will increase. So whenever period increases, the frequency decreases. So say the frequency will decrease, because let's say we know that for us to calculate frequency, we said 1 over 1 will give us 1. Now let's say the period is 4. So if we divide 1 divided by 4, we are going to get 0.25. So you can see that if the period increases, then our frequency must decrease. So sometimes you may also encounter a question like, what is the relationship between frequency and the period? So you can say that these two are inversely related to each other, because if one factor increases, the other one must decrease. Then Roman number 2, the mass of the bulb is increased. So this one, the mass has no impact, so we'll just say it will remain the same. Then what else can we encounter apart from these questions? You may be given like the first one, questions like factors which affect period. So the first one, size of the length. So say size of the length of the pendulum. Then the second one, gravitational force, which is gravity. Then apart from this, the angular amplitude. So these are the 3 factors which affect. Then what are the factors that does not affect the period of a pendulum? So the factors that does not affect the period of a pendulum, the first one is mass of the bulb. Then the second one is size of the bulb. Then the third one is also, apart from the size, shape of the bulb. So these are questions that you may encounter. Then the other questions that you may encounter here are questions like, if an experiment involves pendulum is done on Earth and the same is repeated on the moon, what could be the observation? So the observations is that on the moon the period will be greater than that on Earth. The reason is just that the gravitation on the moon is less than on Earth. Okay, so now we have another question where want to look at a vernier caliper here. So the question A, what is the reading of the vernier caliper? So how do you find the reading? Even here, first we'll begin by considering. So first we'll begin with our main scale. So under main scale, we just have to write down the reading on the main scale that is just before 0. So our 0 is here, so we want to look at this small line here. So we can see that the number before this line is 8. So if we go to the left side, this should be a number less than 8, which is 7. So what number is this? So you know that these are smaller lines, each represents a 0.1. So this must be 0.9 for us to have 8. So here we have 7.9. Now I will just give it in millimeters. So I will just say 79 millimeters. Then after that, we are going to look at the vernier scale. So the vernier scale is this scale here. We can see that we are given. So we have the vernier scale, then the main scale here. Then under the vernier scale, we just have to find the graduation mark on the vernier scale that lines up exactly with a mark on the main scale. So which line is this? Is just this one. We can see that the line on the upper aligns with the line below. So we have to count. We have this 1, 2, 3, 4. So this is on number 5. So we know that we are going to multiply by 0.1. So 5 times 0.1 will give us 0.5 millimeters, which is, if we add 79 plus 0.5, we get 79.5 millimeters as our readings. Then for question B, write in words the SI units of the following physical quantities and state their symbols. Velocity, so we know that this is meter per second. Then the symbol is this one. Then temperature is Kelvin. Here we have K. Acceleration is meter per squared second. Then here we have m/s squared. Then also the other questions that may be given here is you just have to look at the importance of a vernier caliper, the use. Then also, what is the practical? If you look at the practical in real life, what is the use of a vernier caliper? So you just have to look into that. Okay, so now we move on to a question where we are dealing with mass on the moon and the mass or weight on Earth. So this question, a man of mass 75 kg on Earth goes to the moon where the gravitational field strength is 1.6 kilograms. Question A, what is the mass of the man on the moon? So the concept here is, if this man, so we are saying the mass is 75 kg on Earth, then what would be the mass of this person on the moon? So we are going to have 75 kg. Why? Mass is constant, so mass does not change, because mass is just defined as the amount of matter present in an object. So if you take a material, a person with a certain mass on Earth, then you move to the moon, that person or object will still contain the same amount of matter. Matter will not change. So if mass does not change, then what changes? So to find that what will change. The reason behind is the gravity. What is affected by gravity? So for question B, what is the weight of the man on the moon? So this will be Now weight is equal to mass multiplied by gravity. So the mass is 75, then gravity on moon is 1.6. So if you multiply 75 by 1.6, you get 120. So the weight is 120. Now what if the question was to find the weight of this person on Earth? So the formula will not change. What changes is now gravity. So the mass is still 75, then our gravity now is 10. So if you multiply, you get 750 newtons. So we can say that the mass of an object on Earth is greater than the mass of an object on Moon, and the reason is the gravitational field strength on Earth is much greater than that on Moon. Then the other thing that you can look at under mass and weight is the differences between mass and weight, of which the first one is the one that we have looked at here, which is mass is constant while weight changes. Then the second one, mass is a scalar quantity. Mass only contains the magnitude, there is no direction. Like you can't say this object has 75 kg east. That can't make sense. So mass is a scalar quantity while weight is a vector. Under weight we have the magnitude, which is the strength, then the direction where that force is going to. Then the other difference, mass is measured in it can be kilograms or grams, while weight is measured in newtons. Okay, so now we have another question. Here we are dealing with density. What is the difference between density and relative density? So we'll say it's just the mass per unit volume. Now what of relative density is a ratio. So wow, relative density is a ratio. So we define relative density as the density of a substance compared to density of water. So let's look at question B. Figure P2.1 shows a cuboid container that has a 5 centimeter square base and contains water to a height of 6 centimeters. So how do you deal with questions like this where you're told to find the volume? So we can see that we have these two base distances, which is they are equal in size. So this should be LL. Then we have the height here. So how can we find the volume of water? So this is a regular object of which we are just going to use the actual formula. So which is volume is equal to L times L. So whenever the bases are the same, you multiply L times L, which is volume is equal to 5 centimeters times 5 centimeters multiplied by 6 centimeters, which is 5 times 5 will give us 25. Then if we multiply 25 times 6 will give us 150. Remember, the volume must be raised to the power 3. Then we have question 2. A stone is immersed into the water in the cuboid, causing the water to rise to a height of 8 centimeters. Determine the volume of the stone. So we know that the shape of a stone is considered to be irregular. So what happens if we immerse the stone in water? So we know that the water level will rise to a new height. So this time we need to find the second volume, and we call this volume as our final volume. So the volume before the stone was immersed is initial, and of which our initial is 150. So the new height is just 8 centimeters. So let's find our new volume here. Then we can now look at the volume of the stone. So we know that the base will not change, is still L times L. Then what will change is the value of H. So L is 5 centimeters multiplied by another 5 centimeters times our new height, which is 2 centimeters. Sorry, which is 8 centimeters. So 5 times 5 is 25 times 8, we get 200 cubic centimeters. So this is our volume 2, which is final volume. So now how do you find the volume of a stone? So you say volume is equal to volume 2, which is final volume, minus initial volume. Volume 2 is 200 cubic centimeters minus 150 cubic centimeters, which is equal to 50 cubic centimeters as our final answer. Then we can also find the same final answer like this. So we'll say volume is equal to L times H. So the length is still 5 centimeters times another 5 centimeters. Now let's look at the height. So before the stone was immersed, the height was 6 centimeters. After the immersion, the height is 8 centimeters. So we can find the difference. 8 minus 6, we get 2. So let's just put 2 centimeters here. So 5 times 5 is 25 times 2. We can see that we are still getting the same answer. So this one will just give us a direct volume of the stone. Then after we have found the volume, we can now proceed by finding the density. So if the mass of the stone is 80 grams, calculate the density of the stone. So density is equal to mass over volume. So the mass is given 80 grams over the volume. Now use the volume of the stone, which is 50 cubic centimeters. So what is 80 divided by 50? This is giving me 1.6 grams per cubic centimeters. So these are some of the questions that you may encounter. Then you have to look at the definition for relative density, of which we have to find that, the difference, then definition for density. Then sometimes you may be given a question, you calculate the certain density. Then if the question comes, will this substance or object float in water, or is it going to sink? So if you want to know whether the object is floating or sinking, you just have to compare the density. So if the density is greater than that of water, then the substance will float. Then the opposite is also true. Okay, so now we have a question where we are given a velocity time graph. Figure B 3.1 shows the graph of a car that moved from a residential area into town. Okay, so then we can see that we have been given some letters. So describe the motion of the car from AB. So let's analyze AB. So AB is just a straight line here. And whenever we have a slanting straight line, then our conclusion is we have constant acceleration. Now, if this line is moving in this direction, we are saying the acceleration is constant. But if you want to look at the speed, then you need to say that the speed or the velocity, since we are looking for velocity, the velocity is increasing. Because if, let's say, if this is our 0, if you have 1, 2, 3, 4, 5, 6, this is our 1, 2. So if I'm at this point, the velocity is 1. If I move at this point, the velocity is 2. If I move at this point, the velocity will be 3. So we can see that as we are moving up, the velocity is increasing. Then for what is for BC, so BC we can see that we have the horizontal line which is parallel to the x-axis. Under this one we are going to have a constant velocity. Now what are we supposed to know when the velocity is constant? Then the acceleration must be equal to 0. Why? We know that acceleration is defined as the rate of change of velocity. So we only have acceleration when the velocity is changing. If the velocity is not changing, then the acceleration is 0. So in our case, we can summarize that acceleration is 0 when an object is at rest, which is if an object is not in motion. Then the second one, the acceleration is also 0 when the velocity is constant. So at this point BC, the acceleration is 0. Then for CD, we are going to have constant retardation or deceleration. So we'll just say retardation. Now retardation is when the line is slanting down. So here velocity, if we look at the velocity, is decreasing because an object is coming to a stop. So that's what we can see here. Then what else can we be asked from here? We can also be asked to do some calculations like find the acceleration in the first 2 seconds. So the acceleration will be, acceleration is equal to final velocity minus initial over time taken. So if we want to find the acceleration between AB, A is our starting point, so this is our initial. Then we know that B is our final here. So the final velocity, we need to get the number in the y-axis, which is 6 minus the initial is 0 over time taken is 2. So 6 minus 0 is 6 over 2, which is, if we divide, we'll get 3 meters per second squared. So this is our acceleration if the question comes to calculate the acceleration. What if the question is asking us to find the retardation in the last 2 seconds? The acceleration, the formula is still the same. The only difference here, we are going to get a negative number. So CD, so C now becomes our initial velocity. Then our D is our final velocity. So the final is 0. So whenever the line touches the x-axis, you have to make sure that where there is final velocity, you put 0. So do not confuse the final velocity with the number here. This number here indicates, or it shows the time. So for you to get the value of velocity, you need to go in the y-axis. So in the y-axis at this point, we have 0. So that's why we are saying the final velocity is just 0 here. Minus the initial at this point. So you do the same. So you move. So you can see that here we are going to get the number, which is 6. So here if you move, you get 6, which is 6 over. Then in time, don't get 8. So what you have to do is, since the acceleration that we are considering is between 6 to 8, so you need to find the difference between 8 and 6. So 8 minus 6, you have over 2. So it's negative 6 over 2, which is giving us negative 3 meters per second squared. So the negative is just indicating that we are dealing with the deceleration. An object is coming to rest, or the speed, or which is the velocity, is decreasing here. Now what if the question comes like find the distance between AB? So we can now do this. So we know that here we have a right angled triangle. So whenever you are told to find the distance, you use this formula. Distance is equal to half BH if what you have is a right angle triangle. So B is this distance from here up to here, which is just 2. Then the height is this distance, vertical, which is 6. You get this number here, 6, which is 2 times 6 is 12 divided by 2. We get 6 meters as our distance. What if we want the total distance? So the total distance now, this shape here is giving us a trapezium. So total distance, you say distance is equal to half A plus B multiplied by H. Then from the formula, A is just the distance on top here. Then B is the distance from 0 up to 8. Then the height is still 6. So let's find the total distance. So the total distance will be, our A is the number from here up to here, which is you go into the x-axis, so we have 2 and 6. So you find the difference, 6 minus 2, we get 4. Then plus our B is just 8, our height is still 6. So 4 plus 80 will give us 12 times 6 over 2. So 2 here is 1, 2 here is 3. 3 times 12, we get 36 meters as our total distance. So this is what you are supposed to do. So if the question is asking you to find a distance and you have a shape of a trapezium, you use this formula here. Then if it's a triangle, you use half BH. Then if it is a rectangle, you use L times B. Now let's look at the other question that we can be asked here. What was the acceleration when the car was moving with a constant velocity? So this is a point that you are supposed to have in mind. Whenever we have a constant velocity, then our acceleration is just equal to 0. So there is no acceleration when the car is moving with a constant velocity. Then we have question where we are dealing with now a distance time graph. So you need to make sure that you don't have to treat these two questions the same. So the distance time graph, you are going to have a distance in the x-axis, I mean the y-axis, and time in the x-axis. Now do not worry about the units. Here we can see that the distance is in kilometers, then time in hours. So you may be given distance in meters or time in seconds. So the concept, the key, just have to get the concept. So for question A, what is the total distance covered between town A and town B? So let's begin from here. This is where our town A is. This is where our town B. Now, for you to find the total distance, you need to look at this point here. So you need to look at this point. Then you move parallel to the x-axis until this line touches the y-axis. So the number here is our final answer. So if we're having 40 to 60, so these smaller boxes, each box represents 2. So we have 52, 54, 56, 58. So the answer is just 58 kilometers. If it's meters, you give in meters. So that depends on the measurements of our distance at time. So the key point is, under the distance time graph, you don't have to calculate, you don't have to use a formula. What you have to do here is you just have to look at the point where the distance they require. Now at this point where the line is parallel to the x-axis, this means that the person or an object is not moving. Even here, there is no movement. So that is what you have to consider here. Then for question B, the bus stopped at a station between town A and town B. For how long did the bus stop at this station? So let's look at it. So here we'll move, this is where the stopping started. So we move into the x-axis. So this is 2.1. Then here, so the car stopped. Let's just put some letters. Let's say this is our C, this is our D. So the car stopped at D, then it began its journey again at D. So what is the time of this? So you just have to find the difference between this. So say 3 minus 2.2. So 3 minus 2.2, we will get 0.80 hours. So this is what we are going to say. Then for question C, calculate the speed of the bus between town A and the first station. So the first station, according to the letters that we've included, is C. So we need to find the distance at this point. So let's move into the y-axis. So you can see that the distance is 30. Then what is the time? So the time at this point is 2.2. So say speed is equal to distance over time. So the distance is 30 over 2.2. So 30 divided by 2.2. So I'm getting 13.6 kilometers per hour. So that's what you do. Then calculate the average speed for the whole journey. So the average speed for the whole journey, this is just, you just have to say average speed is equal to total distance over total time taken. Then let's go back. Total distance we once calculated, that is 58. So we have 58 kilometers. What is our total time? Our total time will be at this point. So you just have to, because this is where the second stop began. So the distance that was, the time that was taken for this car to cover a distance of 58 is just 4. So it's 58 divided by 4 hours. So 58 divided by 4, you get 14.5 kilometers per hour. Then for question E, mention one consequence of overspeeding. So the consequence of overspeeding, it may cause accidents. Then if we go back to this diagram, you may be asked a question like this: where do we have a point or points where we have the acceleration? No. So the acceleration from the diagram is 0. So from the distance time graph, the explanation is like this: whenever you have a straight line under distance time graph, the acceleration is 0. So the straight line indicates a constant speed or velocity, and whenever we have a constant velocity, the acceleration is 0. But if you have maybe a line like this, if it's forming a curve, then there is acceleration. You might have an acceleration, and if it's moving upward, the acceleration is positive. Then if it is bending like this, the acceleration is negative. That is the interpretation. So for you to have the acceleration under distance time graph, you need to have a curve that is not straight. Okay, so now let's have this question where we can now combine the acceleration with now the force and the mass. So this time we want to look at the resultant force and the acceleration and the mass. So this is just the Newton second law of motion. So figure 2.1 shows some of the forces acting on a car of mass 800 kilograms. So direction of motion, driving force, which is a 2000 newtons, then total drag force. Then A, state the size of the total drag force when the car is traveling at constant speed. So this is a very important point that you need to have in mind. So whenever the speed is constant, the acceleration must be equal to 0. If the acceleration is equal to 0, then the force, which is the resultant force, must be equal to 0. So how can we have a resultant force of 0? So you can see that we have two arrows pointing in opposite directions. So we need to find the difference in between the two numbers. So if the driving force is 2000, what number can we add with 2000 to give us 0? So this will be a negative 2000 newtons. So that if we add 2000 minus 2000 will give us a 0. So the drag force is just equal to 2000. We won't put a negative. We know that the drag force has a negative in it, so drag force is equal to 2000, which is negative 2000. So that if we are to find the net force, we'll say 2000 minus 2000, we get the resultant force of what? 0. Okay, so now let's go to question B. If the driving force is now increased to 3200, find the resultant force on the car at this instant. So this time we can now find net force. So net force will be the increased driving force, which is 3200 newtons, minus the drag force is still 2000. So if you find the difference, you get a 1200 newtons. So you can see that since we have the net force, we can also find the acceleration. So which formula are we supposed to use? So the formula that relates acceleration, mass, and force is this formula. Force is equal to mass multiplied by the acceleration. So this is the Newton's second law of motion, which says that the acceleration of an object is directly proportional to the force causing it and inversely proportional to its mass. So for us to now solve for acceleration, we can divide by m. So force is equal to force over m will give us the acceleration. So what is our mass? Our mass is just 800. Then what is our force? Force is 1200. So 1200 over 800 will give us the acceleration that was produced. So I'm getting 1.5 meters per second squared. So some stuff that you are supposed to know here is that make sure as you're calculating, the mass should be in kg, then the force we know is Newton, then the acceleration should be in meters per second squared or Newton per kg, so that depends. Okay, so now we have a question for moment. Figure B2.1 is a uniform plank of length 100 cm kept in equilibrium by 3 kg and 1 kg mass, placed 10 cm and 20 cm from each end respectively. So there are two moments here. There is a moment 1 here, then we have moment 2. Calculate the moment for 3 kg mass. So moment is equal to force multiplied by distance. So in our case, the force is, we are going to find the weight of 3 kg. So weight is equal to mass times gravity. So the mass is 3, gravity is 10. So the force that is trying to pull this down is 30. So say 30, then times what's the distance? So the distance from the point of action to the pivot, we can see that we have 20 centimeters. Now whenever you are calculating moment, you need to make sure that the distance is in meters. So say 1 meter is equivalent to 100 centimeters. So 20 centimeters, how can we convert it? So the simplest way we are saying here is just whenever you are converting distance from centimeter to meters, you divide by 100. So 20 divided by 100, you get 0.2 meters. So this is the distance that we are going to use here, which is this will just give us 6 Newton meters as our moment. Then for 2, weight of the plank. So for us to find the weight of the plank, let's find the moment 2. So now for us to find moment 2, first let's find the weight for 1 kg. So weight is equal to mass times gravity, which is 1 times. Now the distance here is 50 centimeters. So 50 centimeters, if we divide the 50 by 100, you get 0.5 our distance. Now we know that the weight will give us 10 newtons. Now let's find the moment. What is the moment? So say moment is equal to force times distance. So the force is 10 times the distance is 0.5 meters. So if we multiply, we get 5 Newton meters. So we can see that moment 1 is 6, moment 2 is 5. So there should be another force that is helping these to balance. Now let's look at this meter rule. So we can see that it has a length of 100 centimeters. So if we are able to find the half of this distance, we'll be able to calculate the force that was played by this Newton meter. So we'll say this is the force. Now if this is 50 centimeters as our distance, then what is the distance from here up to here? So look at this point. Here we have 20, then here we have 10, 20 here, so this is 30. So if the total distance is 50, so 50 minus 30, this means that this has a 20 centimeters. So we can now find moment, the other moment. So say moment, for us to find the other moment, we only have one distance. What do you do? We equate these. So say moment 1 is equal to moment 2 plus moment 3. Moment 1 is 6.6 Newton meters. Moment 2 we have 0.2 meters times the force is what we are solving for. Moment 3 is just 5 Newton meters. So 6 Newton meters. 0.2 times F is 0.2 meters F plus 5 Newton meters. So we correct the like term. So this will give us 6 Newton meters minus 5 Newton meters, which is equivalent to 0.2 meter F. So 6 minus 5 will give us 1 Newton meter is equal to 0.2 meter F. So we divide by 0.2, also here by 0.2. So F is equal to, so 1 divided by 0.2, I'm getting 5 newtons. So this was the force that was played by this meter rule, so which is the Planck. So that is the answer here. Then state one application of the above setup. It is used in seesaw. Then we have question. This question where we have a pulley system. So figure 4.1 shows a pulley system used to lift a load of 9,600 using an effort of 2,400 through a vertical distance of this one. Okay. Then the first one is calculate mechanical advantage. So mechanical advantage is equal to load over effort. So the load is this distance, which is 9,600 newtons over what's our effort. So our effort is this number here. So the effort will be over 2,400 newtons. So the newtons can cancel. So 9,600 divided by 2,400, our mechanical advantage is just equal to 0. Then for question B, we want the velocity ratio. So velocity ratio, we just have to count the number of pulleys. So we have 1, 2, 3, 4, 5. So our velocity ratio is equal to 5. And remember, if the efficiency is not 100%, then the velocity ratio must be greater than 100. Now for question C, we just want efficiency. So efficiency is equal to mechanical advantage over velocity ratio times 100%. So mechanical advantage is 4 over 5 times 100%. So 4 times 100 will give us 400% over 5. 5 into 100 will give us 80%. So sometimes you may be given a percentage and asked to find the efficiency. So it's the same. You are given efficiency and maybe asked to find mechanical advantage or velocity ratio. So you can just use this formula. Then calculate the distance moved by the effort. So the formula is velocity ratio is equal to distance moved by effort over distance moved by the load. So velocity ratio we know is 5. Now let's look at distance moved by the load. So here through a vertical distance of 20 meters. So 20 meters is the distance moved by the load. So say DE is equal to 20 meters over 1, you cross multiply. So whenever you are solving for distance moved by an effort, just multiply the distance moved by the load with the velocity ratio, which is giving us 100 meters as our final answer. Okay, so now we have another question from simple machines. So figure B3.1 shows a ramp being used to lift a box weighing 480 newtons through a distance of 3 meters and a height of 1 meter by applying a force F of 200 newtons. So question A, state the meaning of the term simple machine. So say a simple machine is a device which uses less effort to overcome a huge load. So in a simpler language, we just say a machine is a device that makes the work to be easy. Then calculate the mechanical advantage of the ramp. So mechanical advantage, we are saying is L over effort. So let's go back to the information. So the load is just the weight. So we can see we are told a box weighing 480. So 480 is our load. Then 200 is our effort. So say 480 newtons divided by 200. Then 480 divided by 200, I'm getting 2.4. So that's our mechanical advantage. Then for question C, the efficiency. So the efficiency is equal to mechanical advantage over velocity ratio times 100%. So mechanical advantage is 2.4. What of velocity ratio? How do we find the velocity ratio for an inclined plane? So for this one, there is this slanting distance with a value of 3 meters. Then there is this perpendicular height with the value of 1 meter. So velocity ratio is just the ratio between these two numbers. So say its distance 3 meters moved by the effort over 1.0 distance moved by the load. So which is 3 as just the number. So we'll say 2.4 over 3 times 100%. So this will give us 240% over 3, which is giving us 80%. So these are some of the questions that we've just considered. And for this video, we just consider random. We have considered random questions from grade 10 work. So if you find this video useful, give it a thumbs up. Then I'll look into part 2, where I'll focus on maybe grade 11 and 12. So that's it for this video. Thanks for watching.